Hey everyone, a very happy Tuesday and welcome back to our ARM Tech Talk series. This is the place for the latest and greatest trends, technologies, and best practices from ARM and our ecosystem partners. I'm your host, Tobias McBride, and I'm thrilled to be joined today by Stephen Su from ARM, who's going to be talking about sparking the revolution for cloud native and software defined smart vision on ARM. Super excited to have him hosting today's Tech Talk. Before we do go into the content for today, if you've attended one of these before, you know the drill with how we do this. I've just got a couple of housekeeping slides to go through. Stephen, if you wouldn't mind heading to the next slide, that'd be great, because I'd love to tell people how they can get involved in the conversation today. So in addition to asking questions in the Q&A box at the bottom of the Zoom menu screen, so please do so when we get to the end of the talk. We'd love to answer those questions. You can also engage with us on social media using the hashtag #ArmTechTalks and on ARM, hashtag on ARM as well. You can view all near enough 80 tech talks on demand. So there's a hell of a lot of content out there for you to watch. So please do go and check it out. That's on youtube.com/ARM, and make sure you subscribe so you don't miss any of our videos. And make sure you sign up for upcoming talks as well on arm.com/tech-talks. And I can give you a little sneak peek as to what's coming up. Stephen, if you wouldn't mind heading to the next slide. On next week, we're joined by our partners Linaro, talking about compiler optimizations for ARM with Linaro benchmarking CI. And then the week after, we've got a Smart City talk, which I'm really excited about. And we're going to be joined, speakers from ARM are going to be joined by Renesas and Arcturus. So that'll be going live very shortly. In fact, should be going live right now. So you'll be able to register for that as soon as you can after this talk. So that's enough for me. That's enough about what's coming up. I'd love to hand over the floor now to Stephen. If we flick to the next slide, you will see a speaker bio, and you also see a photo. But in a second, you're going to see something even better, which is Stephen actually talking to you live about smart vision, about ARM's work with smart vision. So a reminder, please get your questions in during the tech talk in the Zoom menu bar at the bottom using the Q&A box, and we'll get to those at the end. Stephen, it's great you could join us. Thank you so much for taking part in today's ARM Tech Talk. So please take it away. Tell us more about ARM's work with smart vision.
Thank you, Tobias. Hi, my name is Stephen Su, the Senior Segment Marketing Manager in ARM. I'm currently responsible for the product and solution in ARM IoT Smart Vision division. Today's presentation, I'm going to talk about how we are enabling cloud-native development for AI workloads, especially on IoT edge devices through a software-defined smart vision platform. We see cloud-native as a future trend of IoT device. So this is a tech talk that I'm going to present to you how and why and what is cloud-native and what all the rationale behind this. Okay, so let's just dive into today's agenda. Here is the agenda for today's presentation. First, what is cloud-native? Cloud native is actually deploying your application, especially for the ML workload, as a collection of containers or microservices instead of just like a typical single executable or just a binary. So today we will start from introducing you the background, the challenge you are facing when deploy ML at the edge, and most important of all, what is the deficiency of the current conventional design flow? No matter you are design what kind of IoT device, could be a vision or not vision, but we'll point out what is the deficiency of the current conventional design flow. With that, you will see what we said cloud native of the future of IoT device. This first topic. Then we move on to that the second bullet point is software defined. So to make it cloud native real, to implement cloud native, the platform itself must be software defined, so that you can deploy your machine learning workload. Let's use smart vision as an example to explain its advantage. Then we will showcase a real demo, combining cloud native, combining software defined that we mentioned, and a real case in smart vision. Finally, is a summary for today. So go over, or we can start from some background. AI and machine learning right now is already deployed in many IoT devices and making a huge difference in various applications across home, smart city, and in various industries, including, for example, smart retail. Particularly in smart vision, it's an exciting market with a huge potential. And AI, machine learning, and smart vision are critical to generate more meaningful data nowadays, enable more seamless interaction between human and the environment, and between the physical world and digital world. So that is the background. Then we start seeing what is the change into the architecture now. So the architecture of future smart vision platform actually is changing. You may see left-hand side this kind of diagram a lot before. Currently, you can see a lot of like single function camera be connected to a local NVR. I think that's the typical type of architecture that you usually see, and to provide service and to provide machine learning function. However, with machine learning largely penetrate into people's life, we can see this kind of typical architecture is far from enough. And we will provide you more reason in my following slide. So there will be many kind of machine learning workload to be connected and to be managed by the cloud. As you can see, in the right hand side is we see like the future deployment through your cloud to develop your workload. Then you deploy that to the IoT edge device. So you can see, for example, human presence or object detection in many other IoT devices. So why are those changes happening? Machine learning is basically everywhere. You need an efficient way to deploy different machine learning workload. It's not only related to deploy those different machine learning workload, and also you need to think about how to deploy that efficiently and how to deploy that across many different multiple platform, because you need so many machine learning workload that you need to cover. So how to find a real efficient way, that's the important thing that you need to think about for your future design. Let's go over the typical development flow that I just mentioned. So as you can see, the diagram in the bottom, this is more, I think many people are familiar with this kind of typical design flow. From left to the right, I can see, you can see usually just start from like training data store. You may get some model from some open source link or some your provider model zoo. You start from there, you get your data, you train your model. Okay, then you optimize it, then you deploy it. Like the diagram here said, okay, you deploy your machine learning on the platform. So what is the problem here? Or I should say, what need to be improved in the future? First is time consuming, or typical flow is needs hardware, software, but actually in the end, there could be no cloud service get involved here. That make your function is limited. So on the other way, it is rigid. So you can see you only deploy like single model deployment onto your platform. So it's not flexible and it's not able to cover your future. So many like machine learning workload you need to cover. And also, I think it just deploy like single function is also lack of software ecosystem to help you deploy those multiple application. That's the deficiency that we see from the right now the typical native only development flow. We start, what we propose here is a cloud native design approach. You will see the diagram here. I will get into the detail. And we think this is the solution to address those deficiencies that we just pointed out in my previous slide. So from left-hand side, you can see right now is a collaborate, like a CI/CD environment. You can see as a developer, there could be IoT engineer get involved. There could be application developer. There could be some data science. So all can work together. And then you can start from in the middle side, for example, model rule. That could be per target hardware. You start from some model rule and you go through optimization tool. Then all this flow that actually can be integrated into a cloud environment that we actually provide this kind of environment. We call it virtual hardware. It's a virtualized hardware as a model on the cloud. So we see from developer collaborate together, then you have a flow to go to the cloud to go into this kind of circle to retrain the model. Not only to retrain, you can also debug. After you are happy with this flow, then you can use the package tool then to package the model. Then you can deploy to, like here said, deploy to multiple containers through the container and to deploy that to different hardware that we list here. So you can notice that there is a blue square here that we mentioned. It's the ARM system ready. basically it's a spec to minimize those fragmentation, which in the following slide we will describe more. But you can now see through this cloud native integration that you can allow you to deploy multiple machine learning workload to across different machine learning platform. So now the target platform will allow you to deploy multiple container image and multiple microservices to support various machine learning workload and service. And you can also see that the platform here mentioned should be software defined. So basically that is the basic design framework that we see should be the future IoT device need to support. Then yeah, since the solution will be a software-defined platform, so let's take smart vision as an important example to show you how to build a software-defined platform for smart vision. Since we mentioned the smart vision is an important and huge potential market, then how to build that into this market. Right. In this slide, we'll point out in our vision, how does a smart vision platform work? So first, it's enable the AI and mirror machine learning deployed at the edge. So you can see up the container, there's a vision-related algorithm or camera services to deploy through the container. An AI application is developed in the cloud. You can see there is a cloud service provider and deploy as a container or microservice into the edge. So this is the diagram we like to say, the first point. And the second, after we enable AI, since everything connected to the cloud, so the platform must be secured enough, then we will show how to cover that security part. Then after that, and remote manage of the cloud service provider, because device will connect to the cloud service to provide machine learning service. So they must be remote managed by the cloud service, and it requires tight integration of the device and its software stack with what we call CSP, this cloud service provider. And then the platform itself, like right-hand side, cloud software-defined camera platform. So the platform itself could be heterogeneous. Let's say, like you can have your NPU, GPU, or ISP. That's the platform. Most important of all is this platform must be virtualized, since the device feature can be improved, or the benefit is if you virtualize the platform, you make it software defined, so that can see you can deploy your service from cloud service provider. And then the device feature can be improved or even added on demand, making the solution platform agnostic and software defined. So overall, this is how what we see the software-defined camera or software-defined smart vision platform, how that will work. Yep. So previous slide is the concept. Then how we can build it? We can start from the firmware, the software, because excuse me. So the fundamental requirement is to enable cloud native and make the platform software defined. So to build a standard-based software for abstraction, I think that's the first step. So here we bring in two key standards. We take the standard-driven software enablement strategy for this one. One is ARM system ready, and another is as shown here, the PSA, which we call platform security architecture. So start from ARM system ready. ARM system ready standardize how the standard OS interact with the ARM hardware. There is base system architecture, there is base boot requirement, and there is also secure boot requirement as well. So we define that to minimize, eliminate the fragmentation. So the standard OS will just work if your platform is system ready compliance. On top of that, as I mentioned, we will touch upon the security part. So PSA is the platform security architecture, which is set the standard of IoT security framework and certification. There are security model, there are firmware framework and security service API, those things to help you to reach your security target. Through this standard-driven software, then we can set the foundations of being able to write your application. And now, because your platform is software defined, it's virtualized, and you can achieve is you write your application once, then you can deploy that anywhere to on Arm's platform. So that is our envision for the software and in their standard driven. Look into the detail. We need to mention there is an important layer we call EWO. You can see here is EWO stands for Edge Workload Abstraction and Orchestration Layer. It's a reference implementation of the software layer. Now you can see the link is here. It's a reference implementation. Provide users with a standard-based framework, which you can use container at the edge. So overall, the software structure will look like this. You have UV, U-boot. Once the device is system ready, IR here, which means IoT ready. So you can have, once your IoT device is system ready IR compliance, you can expect the standard, for example, Linux or kernel, it just can boot on your device. Since now the fragmentation, some difference in hardware has been eliminated. On top of that, you can see the EWO, just the reference framework that allow you to deploy your container at the edge. Then on top of that, you can see there could be video capture container to help you to capture video. And after that, there could be ML inference container, there could be application container. Then you can combine all these functions, then talk to your cloud service. So this is overall how we see the ecosystem would look like. So move on to enable cloud native workload development and software defined, the concept that we just mentioned. ARM provides three main solution enablement for this type of concept. From left side, a reference platform with ARM system ready that we just emphasized. So you can expect with that reference hardware, once you have your OS, build up your OS, that software actually can cross different platforms once your device is system ready appliance. So this is the first. And then there should be software stack based on Yocto, which is we call it reference software stack. It's a software stack based on Yocto, and the EWO layer that we just mentioned, as I mentioned, that's EWO that we just explained. Combine this, we also implement a reference use case and open source it for public to access, which I will explain more in my following slide. It's a traffic monitoring use case that we see. We can show you how we combine all this system ready reference platform software stack, then how to really use that to implement a use case. Yeah, we walk you through the software. So there's concept of cloud native, there's software defined, how to make platform as software defined. Then we can spend some time on this one is the platform, since we also talk about the reference hardware. So I think still like from that three concept, so we have reference platform. ARM Corestone 1000 is the ARM Corestone, let's explain this first, is our reference design. So we provide key component here, and customer actually can, based on that, with the extension port to connect to your IP based on your requirement. Maybe the ISP, maybe it's other like machine learning accelerator to implement this smart vision function. But still, we start to achieve real software defined. It's important one is we also provide standardized software, like I point out here is the PSA certified and also the system ready to help to finish your design easily and quickly. So this is the hardware enablement about the software defined platform. Right. We walk you through the software and hardware reference. now we are going to the step to show you how combining all these factors, how these different parts really work together. So this is the reference implementation, as I mentioned, with ARM system ready, build your Yocto OS for example, one platform here, but you can expect once other platform is system ready compliance, that OS actually can migrate between different platform, like we mentioned here. There could be Rockpie, there could be IMX, AM, NSP platform, or there could be Cornerstone 1000, which is our in-house development. So left-hand side is with more detail about the software layer. So you can see, but basically the overall structure still look the same. So you can see from the bottom on the hardware, then you go to you boot UEFI level, then you go to, for example, Yocto layer to put up your system. Then there is the EO layer to allow you to deploy your container. On top of that, you can start to build different use case and deploy that use the container and also microservices. And just give you a heads up that this is the demo, that real demo that we are going to show you how the software layer that we point out here and how that software to work on those hardware platform that we just mentioned and make a smart vision platform work. So some deployment examples that I'm going to show you. This is the smart retail example that we mentioned. So start from the hardware platform. You can see here that ARM-based hardware platform. On top of that, yes, Yocto-based OS. So, but you can see through the containerized, then you can deploy. Your function can be like break down into different container and start to deploy that on your platform. So there could be pre-processing or some web UI container. This is still a smart vision platform. So you'll see the video capture, so see the inference container. You will see also other container is the container how to integrate with cloud service provider. You can see the container here. That could be, since right now your workload is containerized, you can actually, depend on your requirement or latency, you can deploy that container, inference container onto your device on local or execute that on the service provider is also okay, depend on your requirement. Then since there is CSP integration container, so you can upstream those only necessary information back to the cloud, then the cloud service provider can provide you that kind of dashboard to tell you those information in real time. With that, since smart retail is a wide application, then this is how that you can possibly to implement. For example, there could be some cashless checkout or store maintenance or some manage or some safety. That's how you deal with so many different kind of machine learning workload on the smart retail market. Smart city is another, I think it's another good example that need to deploy complex and also multiple machine learning capability on demand. For example, at the intersection with different time or location, you will need different machine learning function. In some traffic time, you may focus on the vehicle, for example. In other time, you may need to track the person, for example, and doing pedestrian detection or some distance, social distance checking, and much more. So I think smart city is another interesting example to show you right now for machine learning deployment. It's not just a single function. You need efficient ways to allow you to deploy different workload in different time. Right. We go through smart retail and we explain you smart city. An important example that I want to show you is actually that we make this kind of example implementation with AWS service to show you that deploy cloud native workload and make the platform software defined is actually important for your application. It's actually real. So you can see this still follow cloud native and also software defined concept. The inference container can be deployed on the edge, on device through the AWS IoT Greengrass, and also this inference can also go to the cloud as well. So you can do that in the cloud or deploy that on the edge. This is very flexible. That means the ML model, or we call the inference, or we call it ML service, you can deploy that on demand, which means or change that or update that through the device life cycle. I think that is the important step to really make your solution flexible enough. And one thing to point out is we implement this kind of implementation, but also this is in its example implementation that we work with scenario. So there's actually an integration example as the link point out here that if you are interested, this one can provide you with more important information with the link here. Right, so previous slide, it's the showing you the software stack and also how this can integrate with the cloud service provider, for example, AWS here. The reference, if you don't have hardware platform, basically that can run those service. So here we shows the reference software stack will run seamlessly just on ARM system ready compliant hardware platform. For example, the rock chip, for example, the NSP, and also our ARM in-house personal reference design. With that really make your platform really powerful to address any machine learning workload, that kind of challenge. So the software can be deployed seamless as we mentioned, this kind of system-ready platform. The software that you build can just cross the platform. You won't be limited by one platform. And also the machine learning service on top of that can be deployed on demand, can be updated, can be changed, follow your requirement. That's the benefit and the beauty when you make your device flow like cloud native and also the platform software defined. So we will go to, before we dive into the demonstration, just some key points to mention. So the demo that we're going to show you is a cloud native workload development, and also show you how the software defined smart vision platform will work. And combining the reference software stack we just introduced to you, and also the system-ready IR compliant concept for the hardware platform, really a demo to show you how you combine all this important part, then how the platform will work. Let me stop sharing the slide and I jump into, just give me 1 second to go to the video.
No worries, Stephen. Yeah, while you were, and this is really great so far, audience, I hope you're enjoying it just as much as me. You're getting a lot of great insights. While Stephen loads up the video, get your questions in using the Q&A box, because we've got this demo now, and then soon after the demo, and we'll have a Q&A session. So Stephen's just getting the video up now. I'll let him play that, and I'll let you carry on. But yeah, do get your questions in.
We'll start the demo by introducing the different components that make up the demo. Here we have 3 ARM-based hardware platforms which are connected to a host machine, and we'll be communicating with these platforms through the host machine here. And we also have a stack of 3 web cameras. They're USB cameras which are connected to the hardware platform, and they are pointed at a video which is running in loop. The idea is to feed the video into the live video into these hardware platforms so that they can do the processing of these videos frames on the device. The 3 hardware platforms here are completely different from each other. They use different SoCs and are built by different SoC vendors. So here we've got the IMX 8M Plus then we've got the Raspberry Pi 4B. Here we've got the Rockchip RK3399 Pro D platform. The only similarity between these platforms is the fact that they are running exactly the same Linux image, and the fact that they are all system ready IR compliant. We'll now move over to the host machine, and here on the left we've got the Raspberry Pi. In the middle we've got the IMX8, and the last one is the Rockchip RK3399 platform. Along with showcasing a single Linux image running on multiple system-ready platforms, we also want to showcase how we can run a single unmodified cloud-native use case implementation across these same multiple devices. In the interest of time, I already have the inference containers running on the IMX8 and the Rockchip platforms, and what I'm going to do now is run the pre-processing containers that will then talk to the edge to the inference container that is already running on the device. On the Raspberry Pi also, I will only instantiate the pre-processing container, which will then communicate with the inference container that is running on the cloud. And we'll be showcasing, and there we can see the video feed being captured from the screen here and being processed in the captured through the Raspberry Pi and being sent to the container running on a cloud instance for inferencing and being displayed back on the traffic monitoring UI. We will now switch tabs so that the inferencing on the other edge devices may also start, and we should see the images appear shortly. The delay on the edge device is slightly longer because the performance is much lower and the model is currently not optimized to run on edge devices. You can see the video is now playing on all three devices. This use case was developed and deployed in collaboration with Capgemini and ARM. So a big shout out to Capgemini for collaborating with us on creating this use case implementation and this multi-container cloud native traffic monitoring use case example. With this demo, we have showcased how we can leverage programs like System Ready to deploy a consistent software stack across multiple ARM-based devices, and how we can deploy cloud-native workloads across multiple devices as well, without having to make any changes to the application or having to undergo any porting effort or development costs associated with that. We can therefore say you can write once and deploy everywhere with ARM technology. Thank you for watching. For more information on System Ready, please visit arm.com.
Okay, let me get back to my slide. Hope you enjoy the demo. Okay, get back to the slide. So that is the demonstration to show you how the concept that we just bring up to you, cloud native workload deployment, software defined, and we implement these two by using the smart vision to show you that's really doable, and that's the real example deployment. And also combine those different software stack and also the system ready so that you can make your software portable. Then I will go into today's summary. Typical development is not capable to handle the future ML workload because it's not flexible enough. The machine learning, AI, ML, smart vision basically is everywhere. If the platform just like a single function, that's not going to survive for future machine learning workload and challenge. You need a new architecture to deploy ML workload at the edge, which is cloud native and software defined. ARM is leading in this by these three strategies that we enable. First one is a cloud native design framework, software defined. Then we open source those use case implementation for you to you can try once you have, for example, RackPi or other platform, you can test that by yourself. So if you are a developer, welcome to try the software link that we just provide in this presentation. If you are SIP, you want to build your SOC solution, that will come to contact us as well. Or you are OEM, ODM interested about what kind of service can be provided with this cloud native deployment, also welcome to contact with us. I hope you enjoy and find today's presentation useful. Then we can have some time for the Q&A section.
Let's do it. Thank you, Stephen. That was awesome. Thank you so much for a great tech talk and a great demo. I've got a couple of questions, and I'd love to hear from the audience if you've got any questions as well. There was one that came in, but unfortunately it came through, there were some issues viewing it at my end. It was almost certainly my Zoom. So if you wouldn't mind just responding to that, or if you have already, in fact, they have already. So we'll definitely get to Nilash's question as well after I've got a couple of questions of my own. So do get your questions in. So Stephen, I'd love to hear your, and actually you can probably stop sharing your screen if you want to, and it could just be us two having a conversation. I'd love to hear a bit more about the, we've spoken a lot about the cloud native software defined camera today. I'd love to hear a bit more about the software side of things, the software resources that ARM provides to make that cloud native and software defined camera possible. Could you talk a bit more about the software, for example, the tool chain, the software resources that ARM provides to facilitate that?
Oh, yes. So I need to emphasize here, because we provide a lot of software resource to make it a software defined, make the cloud native flow possible. The first one, because not many people notice that, but I would like to just emphasize that again, is that containerized, the EVO software layer that we just mentioned. We implement that and make it that open source. I really recommend, if you are a developer, you want to try, you can start from that EVO layer, because that allows you to deploy the container microservice into your IoT device. So I think that's the starting point that you need to really experience what's the change or revolution start there. With that, if you still need more, I would encourage people to go to like develop.arm.com. There are a bunch of resources there, including software and also some introduction documentation of the hardware. So many resources there.
No, definitely. Thank you, Stephen. Yeah, develop@arm.com is a great resource. And there's opportunity for you to look at our learning paths, our developer learning paths on arm.com/developer and our developer hub as well. So between the developer hub, and our ARM experts there and ARM ambassadors there and the content there and the developer.arm.com pages, we've got you covered on this. So do reach out if you've got any questions on that, and definitely do check out that great content that the team's produced. So one of the other things that, spoken a lot about these, the great buzzwords, cloud native, software defined camera, and more buzzwords, I'd argue, are probably CI/CD and MLOps, right? CI/CD and MLOps, they're popular software development and deployment mechanisms. How could this cloud native software defined camera be seamlessly integrated with CI/CD and MLOps flows?
Yes. So yeah, thanks for the question. It is a very important question, I think, because right now more and more machine learning developer, they need to work with us. If you still remember, there's one slide in my presentation point out how this cloud native architecture work. So you can see there is IoT developer, there is data science, there could be engineering, how these different developer can work together. CI/CD is the trend that industry is going to. And as I pointed in that slide, you can see the whole cloud native flow that we just mentioned is actually seamless, can be integrated into that CI/CD flow. It's basically like just one coin, two sides. You have cloud native and you have CI/CD, but basically when you use cloud native this flow, you use the CI/CD, so both sides can be seamless integrated. So you can integrate your resource correctly and make you the best come out.
Brilliant. Thank you so much, Stephen. That's great. And that's the kind of software side, right? But now let's talk about the hardware and ARM's product portfolio. ARM's got an extensive product portfolio. I'd love for you to talk about the hardware IP side. What recommendations do we have, and do we have from ARM? And what recommended ARM IPs do we have to run this cloud native software defined vision platform?
So start from more like a vision focus. I would say, please check our www.arm.com. You will see a Cornerstone product family there, which is our IoT solution. We also make a lot of introduction on our website. If you focus on vision, then you may start from Cornerstone 1000 above that level of our solution. So you can see there is a reference invitation, documentation, including CPU. And also that platform actually is very flexible. You can buy your requirement to add or remove the key component. But basically that is the framework of hardware that you can start with. That's for the vision part. And if you are focused on more the audio part, below the Cornerstone 1000, there is 300 series 310, which utilize our powerful Cortex-M 85 and 55 MCU there. It's an MCU, but actually very, very AI capable with our Helium support. So those are hardware platforms that I think the user can start with.
Definitely, thank you. It's great to, I know we talked about Cornerstone 1000, did you say, but the Helium vector extensions are super interesting. It's great to see people already deploying and using them and seeing what's possible there.
Yep.
So we've got a couple of questions that have come in. Nilesh has asked, is there a minimum on-chip SRAM footprint requirement for this use case to meet the performance KPIs?
Oh, yes, that is an important topic. It's like a RAM requirement. Also, some customers, they may concern about the latency, because right now, on top of typical machine learning workload, you still need to run like containerized. I don't have number, but we do have some reference, but I don't have number on hand right now on top of my head. But is there any way that can maybe through the email after the webinar? I think, yeah.
Absolutely, yeah. Do you want to just, if it's okay, Nilesh, what we can do is you can follow up with me directly, and I can connect you with Stephen, or you can just, Stephen, are they okay if I email you directly or contact you directly via email? Is that okay?
Yeah, that's fine.
Yeah, that's no problem. So yeah, do give one of us an email. You'll see my email on the Zoom invite, Nilesh. So, and then I can help connect you with Stephen. But yeah, it'd be great for you to follow up for sure.
Right. So although we can't just like on this webinar, because I don't have the number on top of my head. So some customer may have question about the required hardware resource or the overhead to make your platform really software defined. But I would say, on top of that hardware overheads, think about the future of the machine learning, and think about this kind of flexibility, this kind of advantage that this kind of development can bring up to you, that you can have single platform with many different machine learning workload, and you can fulfill many different kind of application. Important of all is the ML service on top of it can be updated, can be changed on demand by your requirement. So I think that's sometimes we encourage people to think about not just the hardware overhead. You can think about what is the benefit that this kind of cloud native architecture can bring to you.
Brilliant. Thank you, Stephen. And we've had a question come in on, Edwin says, thanks for the presentation. And his question is, given the pressures in the IoT space for a smaller container as far as possible, and the pressure to minimize developer load, how do you see the recent introduction of WebAssembly-based containerization for both FaaS and ML flows affecting the depth of the software and hardware stacks that have been described here?
Yeah. So in ARM, we watched the containerized, I think that kind of technology closely. There's many tiny or some like newer containerized. We watch this closely, but currently we haven't tried that yet. So no like specific comment about that, but we watch that closely, and we see containerized in the IoT device. That will be the future. Yeah.
Amazing, thank you. Well, while we wait for any final questions to come in, Stephen, is there anything else you'd like to say to the audience as a kind of final wrap up or key takeaways you want to reinforce to the audience today?
So as a wrap up, I would encourage people to look at the link that we provide. Especially the one example we point out is the example that we with AWS as a service, because that combined everything, cloud service, like cloud native and also software defined. And important thing is that cloud that we connect to the real and important cloud service provider, AWS, to really show you how this flow can be utilized in a commercial device, commercialized case. So it's real, it's coming, and we show that, we implement that, integrate with AWS. So it's the real like important example I think people can start with. So go to look at that link and give us a feedback.
Absolutely. Thank you so much, Stephen. Thank you, audience, for your great questions that are coming today. Tune in same time next week for another of our own tech talks, where we'll be talking to Lenaro, and that's a really exciting tech talk about the compiler optimizations for their and using their benchmarking CI. So do check that out. The registration is open for that now. The week after that, we're back to talk about smart cities, and we mentioned a bit about it today. So if you like any of this content, then do make sure you sign up as soon as possible to get your seat. So Stephen, thank you so much for a great ARM Tech Talk today. Audience, thank you so much for your questions, and we'll see you again the same time next week for another ARM Tech Talks, where this is the latest and greatest trends, technologies, and best practices from ARM and our ecosystem partners. Thanks so much, Stephen. Thanks so much, everyone.
Thank you.